Hey guys, welcome back to the channel. So today we're gonna talk about pandas. So I have made other videos also on pandas, but that is bits and pieces. I made a video on separate function group by, and also I made a separate video on str accessor. So that is in detail about that function. Then I thought of doing in detailed end-to-end video on uh, pandas library, since I made about NumPy separate video from what are all the things there NumPy and what are all the applications, how do we use. So in that process I also made a separate video on matplotlib and also on cborn and also on sklearn for machine learning. So I thought of doing a separate video on pandas only, not about a single function, but why not to include all the necessary functions when we came across, when we do exploratory data analysis, or when we are performing, or when we build a machine learning model. So we need to work on these functions. So I just wanted to explain, so what are all the things will be useful, and also uh, so few things in data pre-processing. So it is very helpful while preparing a model. Also we need to do some data pre-processing. So in that step, this all these things we are going to talk about, those things will be helpful for us. So let's jump into the session. So I have made from very basic steps how this pandas will be helpful, starting from viewing the data. It could be in any format. It could be in Excel, it could be in CSV format, or it could be in JSON format. So first step is, like, if I wanted to load the data into the my Python environment by using, so so let me import pandas. So why the necessity of importing cborn here is, like, I just wanted to explain each and every step, basic steps to advanced steps with a practical data set. So that is why I just imported inbuilt data set from cborn. So that is why I imported cborn. So this is my data set. So I imported pandas as pd and sns as, sorry, cborn as sns. Then I'm gonna load this Titanic dataset from cborn. So I'm naming my dataset as a df sns dot load dataset, and I'm passing the dataset name, which is Titanic. Then I'll be able to load this inbuilt dataset. Titanic dataset will be loaded successfully. So if I wanted to look at the, let me remove this, first run the only dataset, then let me create another one. So if I wanted to look at the only first 5 rows, then the basic syntax or command is df.head. So df.head will give me the first 5 rows, viewing the first 5 rows. So then if I look at the data, so here you can see a column for survived, and first P class, something like that, and also gender, the passenger gender, passenger age. I don't know what is this. I also don't know this. And a fare, what is a ticket fare, and embarked, and the class, first class, second class, third class, and who the passenger is a man or a woman, something like that, adult male, true or false, deck name, and also embark town, alive or not. So after the Titanic accident, whether this particular person is dead or alive, something like that. We can have alone, or is he traveling alone, or is he traveling along with the family or friends. So this is about a brief a description about the data set. So that is how we can look at a data set. Like, if I pass df dot head, by default it will show us the first 5 rows. So if I wanted to look at the first 10 rows, then I need to pass the 10. Then I'll be able to see the first 10 values. So that is how, if I wanted to look at the top first 5 rows, or first 10 rows, so this is how we can able to get it. And So this is again same thing. And if I wanted to look at the last 5 rows of the data set, that is simple, df dot tail. So if I did not pass anything, it will directly take by default the last 5 rows. So since my data set has 890 rows, so it is taking from 86 to 90, the last 5 rows by default. If I'm passing any variable or any number, then it will take that particular number of data elements. So if I wanted to look at the last 10 rows, then I need to pass number 10 here. Then I'll be able to see all 10 last 10 rows. So that is how we can able to see viewing the last few rows. Df dot tail, it is like a head of the body, tail of the body, something like that. These functions are made like in general, also like in our day-to-day life, how we use the normal terminology. So that is what the beautiness of this Python. So it is like so it is not complicated like other languages, it is very simple. So see, df dot data frame dot head, it will show me the head, like top rows. Tail is like nothing but the bottom rows. So that is how you can understand or you can relate. And if I wanted to look at the information about the data set, so I'm giving df dot info. So this is what if I enter df dot info, then I'll be able to see the information about all the columns. So for example, here with the df dot info function, I'll be able to see the total entries and also the column name with the index, and also the number of elements in the particular column, whether it is any null values are there, or all the rows are, or all the entries are filled with some values or not. And at the same time, we'll be able to look at the D type, the data type of particular column. So here, if I look at the data or a data set in detail, my survived column do not have any null values because total entries are 891. So it is all the 891 fields are filled, and it is a numerical int 64 data type. So similarly, P class and gender, I do not have any null values. So whereas I have some null values in age group, and at the same time, I do have two uh, null values in this embarked, and also I have null values in deck. So this is how we can look at the information about the data set. So one thing I wanted to explain, so I wanted to import some warnings so that I don't want to see any warnings in further. Dot filter warnings. Okay, so if I pass this, if I import and if I use this syntax, then I won't be able to see any warnings. So that is how we can get with the df dot info. And so if I wanted to look at the statistics about my data set, so describe will give me all the stats about the data set, all the numerical columns along with a count, mean, standard deviation, minimum value, 25th quantile, 50th quantile, 75th quantile, and also the maximum value in that particular column. So let me do transpose. Then it will give me a nice visual representation in a different way. Basically, it got transposed. Rows become columns, and column becomes rows. So that is how you can look at all the numerical columns. So it was not included object because by default, if I apply df dot describe, it will only take numerical columns. So I have 1, 2, 3, 4, 5, 6. Only 6 I have. So let me count 1, 2, 3, 4, 5, 6. So that is what whenever I do df dot describe, it by default it will take only numerical columns. If I wanted to include object or categorical columns, I need to mention include d type categorical also here. I need to pass that. So that is how you can look at the summary of statistic by doing df dot describe. That is one thing. And the next thing is like filtering the data, selecting and filtering the data. So if I wanted to, I have, so, and also let me import a cell, and so here I wanted to look at the columns df dot. This syntax df dot column will give me a column names. So if I pass a list of df dot columns, then I'll be able to get the columns in a list format. So these are all my columns in the data set which we imported. So one of the column is age column. So if I wanted to filter the data, so this is my age column, df dot age I'm passing, then I'll be able to get the top 5 rows. Uh, from that selected column. So I can able to take only single column by passing or df the data frame, and you need to mention or you need to pass that column name. Here I am passing the age, and I'm dot head means in that respective column I will get the top 5 rows. And also selecting multiple columns, this is for one column and this is for multiple columns. So if you need to get the information about multiple columns, you need to pass a list inside the df. So here on one square bracket is enough, but here you need to pass the list of column names. Then only we'll be able to look at the data frame correctly. So here df dot I passed list of age and fair. Now I wanted to see, so this is my new data set. Sometimes when we are working on a larger data sets where there are a lot of unnecessary columns are there where we do not need those things. I just wanted to do some analysis on the required columns. Then you just filter it out. Just take those columns and just start the processing. So here that is how you can take it. You can, if you wanted to take multiple columns, then df of pass the list of columns. Then if I wanted to look at the top 5 rows of these two columns, then dot head, something like that. And also I can also apply a condition, like for example from the age row I wanted to get a person whose age is greater than 30, something like that. I just wanted the something like that. I can apply the condition, and also, and I wanted the top 5 rows of with that condition. So here you can see df of age greater than 30. So here if you can see the age, all the we have since I just gave head top 5 rows, these are the my top 5 entries with this condition. So you can see the age is more than 30, the condition satisfied. And also since I gave uh, dot head, then I'll be able to see the top 5 rows with this condition. So that is how you can get a condition, or you can get the data by applying or filtering the rows by a condition. So that is how we can get the, or we can do some filtering. And also this value counts, for example, if I wanted how many females and how many males, here I can able to do that. So this is how we can count. It will basically counts the values in that particular column. So since I wanted a value counts of this gender column, then df of that sex, then dot value counts will give me number of values, and it will count the values, it will count. So if I look at the entire data set, I have male population is around 577, and female population is 314. So this is how you can get the value counts. Basically it is very useful when we have a categorical columns, because we have multiple categorical columns, 4 5, and I just wanted to look at how many categories in that one category, how many values are there, and on how many values are there in other category. So I will be able to get that information by passing this value counts. So that is the use case of this value counts. And if I wanted to look at the unique values, for I'm just passing the same column, and I wanted to know the unique values in this respective columns. So n unique will give me the number of unique values. So since I have only the column filled with a male and female, only two categories. So the unique values are only two. This will give me the column number of unique items or categories in that selected column. Since I selected the gender column, and if I apply n unique, then it will give me the unique categories, and it will count the categories. So number, that is what we can get. And also if I wanted to, I can use some query. This is again comes under like condition. So let me check with the age only. Age greater than 30. Df of query greater than is not supported between instance of string and int. So let's take so actually, if I wanted to use this df dot query, so it has to be a string. So we need to apply the condition or query in a single quote. So I need to pass. So I wanted a data set of female, and also the p class is equal to 1 and fair is greater than 50. So I can apply multiple conditions inside, but all the conditions should be in a single quote, a string. So that is the use case of the query. Here I just apply sex is equal to female. I wanted the female's passenger details, and also p class is equal to 1. P class is equal to 1. Then fair is equal to, or fair is greater than 50. Fair, so these are the values which are greater than the 50. So this is how you can apply some queries as well. This is similarly the SQL query. So we need to apply some queries inside the code, then we'll be able to filter the data with the by some conditions. So that is how we can use this df dot query and filtering rows by multiple conditions. So if I wanted to apply multiple conditions, so we just saw here, uh, this is with a one condition, filtering low by one condition. And here, if I wanted to filter with a multiple condition, I just apply, previously I just applied only the passengers whose age is greater than 30, as well as this time I wanted also the passengers whose age is greater than or more than 30 years, and also whose fare is less than $50 or less than 50, something like that. I want the data with these two conditions. That is how I can able to apply. But we need to remember one thing, this the condition should be in a bracket. Df dot age greater than, this entire condition should be in one bracket, then only the, I mean, the syntax will work out. That is what the syntax designed. Then every query should be in a closed bracket. So you can apply 100 conditions inside, uh, like inside df, but it should be every, each and every condition should be in closed bracket. So that then I applied a df dot head, then I'll be able to get the first 5 rows with this condition. So this is how we can extract the data, extracting or filtering rows by multiple conditions. So next thing is like handling missing data. So this is one of the important concept in pandas, because it is in real life. This is where this the pandas is helpful. So first thing, checking the null values. So if I wanted to see is there any null values are there in my data frame, so we can able to check like df dot is null. So if I do not do dot sum, then it will give me a boolean format of data frame. If I do dot sum, then I'll be able to get all the columns with some null values. So here I do not have any null values in survived, but I can able to see 177 columns or null values, 177 rows in age column are null values. And also there are two null values in embarked, and also we have 688 null values in deck column. So that is how with the syntax df dot is null dot sum we'll be able to see the some of the null values. And also if I wanted to fill the null values, so this is how, if I wanted to fill all the null values with a 0, then I need to do df dot fill na. I need to pass that value constant. So here, if I wanted to fill the value with a 0, then pass 0. If you wanted to fill it with some alphabet also, then you need to pass that alphabet with a single quote or double quote. So you can fill either ways. If whatever the condition or whatever your data set or whatever the column you are filling the null values, though as per your requirement, you can fill it. But the syntax is df dot fill na. Then you need to pass the required constant element. What element you wanted to fill the null values with. So, and also if I like, sometimes whenever I'm working on a very large data set and there are some negligible null values are there, in that case I don't have to fill the null values. I can just ignore it. I can just ignore, or I can just drop the null values. So that is all, that is also we can do with pandas. The syntax is like df dot drop na. So it will drop the null values, then it will give me the head of the data set. So df dot drop na will drop all the null values. So this is basically when we drop, because that doesn't affect the distribution of the data, or we do have very less significant of uh, null value, something like that. In those scenarios only we can do this df dot drop na, or else we need to fill the null values with the mode or something like that, because we cannot delete the null values just like that. So if it does not affect the distribution of the data for other columns, then only we'll be able to perform, or we'll be able to do df dot drop na. So that is how we can drop the null values. And also sometimes if I wanted to fill the null values with a column mean value, so where, like I said, in order to not to disturb the distribution of or skewness of the data, so I need to fill the data with a column mean sometimes, or also mode, column mode, if I am working on a categorical data. So this is how we can fill. So my age column is a numerical column, and I wanted to fill this with the mean values. So if I look at the statistics of my data set, mm, so my age column mean value is 29.69. So I wanted to fill all the null values in age column with 29.69, so that the skewness of the data will not be disturbed, and also we are not going to see any null values in the column. So that is how, that is a one way to fill the null values without impacting the skewness of the data. That is one way to handle the missing values. So by using this the respective column, then fill in a, then I am passing this df dot age dot mean. So in place is equal to true, it will save the original data set with the applied condition. So here I am filling the null values with the particular age column mean, and I need to save the changes. So that I need to pass this in place is equal to true. Then the original data frame will be saved with the changes, whatever the changes we made. So that is how we can fill the null values, or we can handle the null values. And also this is like about data manipulation, renaming the columns. So if I wanted to rename the column, I have a syntax df dot rename, then I need to pass column is equal to, I need to pass a dictionary with the column names. So this is my old column. So I have already this existing column is fair. I wanted to rename it to ticket price, and I need to pass in place is equal to true, so that this changes will be made in the original data frame. So you can see if I run this, then you will be able to see where. So it was previously fair. The column name is fair. Now it got renamed to ticket price. So ticket price. This is how you can rename the columns. And if you are doing in place is equal to true, then the changes will be saved into the original data set. So that is how you can rename the columns. Or if I wanted to change the data, I mean data types. So that is also we can do. Like if I wanted to survived column, where is my survived column? Survived. Here only zeros and ones are there. These are like integer column, int 64 column. Now I wanted to, let me see what is the d type of my survived column in 64. So if I wanted to convert it to different data type, then I can able to do that by using that particular column, which one I wanted to convert or change. Then same column dot as type, then you need to pass the required data type you wanted to be convert or change. If I wanted to convert it to float, then pass float 64, or if I wanted to convert it to object data type, then pass object, something like that. Then we'll be able to see the entire column will be converted into a new data type. So that is how you can change the data types. And sorting the data frame, so sorting like with a minimum to maximum or alphabetical order, something like that, we can also do this sorting values. So now I just wanted to sort the data set with age column, and I wanted top 5 rows. So here age, it will take, so this is already sorted and I'm getting the top 5 rows. So why I'm getting this 0.042, 0.67, because this is not the exact data set. This is a sample data set to work on or for the practice purpose only. So that is the reason why this age 42 or 67, or it could be maybe children's with 4 months or less than 1 year, something like that maybe. So it could be, so that is how. So I need to do dot df dot sort values, then by is equal to age, and also I can apply ascending is equal to, if I give false, then I'll bottom values I'll get. So see, the oldest passenger in the like in the Titanic data set is 80 years old. Next is 74, 71, 71. So something like that. I can able to sort the values with by sorting one column, ascending or descending. So if I do false, then by default, if I do not apply this ascending is equal to true, by default, if I only give by is equal to some column, it will take the ascending values only. So if I want a descending values, then ascending is equal to false. I need to pass so that I'll be able to get the data in a descending order. If I give ascending is equal to false. So this is how we can sort the data. And also next thing is like if I wanted to add a new column. So you need to define that column with the df of that column name. And now I'm just creating a new column randomly, like the existing column with the plus 10 I'm giving, so that a new column will be created. And if I wanted to look at the new column in the data set, so new column is added at the end of the data set. And also see, look at the age, it is 22 here. 22 plus 5 is, sorry, 10 is 32. Since I gave age plus 10, right? So 22 plus 32 and 38 plus 10, 48, 26 plus 10, 36, 35 plus 10, 45, 35 plus 10, 45. So that is how. So if I wanted to create a new column based on my requirement, I can also do it by defining that column. And also you need to, here I just wanted I just created a sample column. And also if I wanted to drop the columns, so I have a syntax for this also. This is like, so this is a column I created just now here, new column, and I wanted to drop it. Sometimes we don't need all the columns for the analysis purpose. And if the data set is very big and we are not going to handle it with a larger size, then we need to delete or drop some columns. So this is how we can drop df dot drop, and you need to specify the column which one you wanted to drop. Column is equal to pass that column name, so that the respective column will be dropped. And also I need to give in place is equal to true, so that these changes will be saved into the original data set. So see here the here the column is there, now it got deleted or dropped. just because I did df dot drop. So that is how we can drop the columns. And this is again about grouping and aggregation, like grouping the columns together with some aggregate function. So this is about grouping data by a column and calculate the mean of each group. So I wanted all the columns to be grouped with the class, and I wanted a mean. And also I don't want all the columns. I just wanted head. What if I give? Okay. Okay, so class, it is the indexed, and I wanted to group all the other columns with the class column and mean value. So this is how these values are the mean values of all other columns which are grouped together with the class column. So that is how we can group a single column. And also this is about aggregating the data, performing multiple aggregation operations on grouped data. So this is only I just applied only mean. So if I wanted mean and also some mean of age and some of the fair amounts, that is also I can able to get. So df dot group by, then this is I wanted to group class with the age, mean age value, and also some of the fairs. Okay, we just replaced with the ticket price, right? So that is why we are getting this error. I need to replace this with ticket price. So now it will work. So see, this is how we can aggregate the data. So I wanted, this is the average age of the passenger from the first class, second class, third class, and this is the sum of the ticket amount from first class, second class, third class. So this is how you can aggregate the data. And if I wanted to apply the pivot tables, that is also we can do with the pandas pivoting tables. The syntax is df dot pivot table, and you need to specify index. I'm giving sex, and also I'm giving the column values, because this is my index and these are my columns. What kind of the column you wanted in columns row? So I wanted class column, so I just given columns is equal to class and values is equal to fair. I wanted fair values. So since it got renamed it to ticket price, I need to change to ticket price, and aggregate function is mean. So if I run this, then I'll be able to see this is gender, female and male, and columns I gave class, first class, second class, third class. This is in columns, column 1, column 2, column 3, and I want average ticket prices from each column. So first class, second class, third class. So this is how we can apply the pivot tables in pandas. And the next thing is like merging and joining the data frames. So I'm just creating another df1 with the existing data set. So from that above data set, I created a new data set from the same data set. I just took only survived and age. And second, another data frame I created with the survived and fair. I am just utilizing the same data frame, and I created other two new data frames. And if I wanted to merge those, the merge data set is like pd dot merge df1 comma df2, data one, data frame 1, data frame 2. On which column you wanted to merge it, you need to specify that column. I wanted to merge on survived column. The common column only we need to mention. Then if I do the merged column, if I wanted to look at the merged column, array yaar, I need to use this ticket price every time. So this is how you can able to merge the two data frames, merge two data frame based on a common key column. Here my common key column is survived. So that is how you can do some merging. And this is about concatenating data frames. So same data frames, I just wanted to concatenate df1 and df2. So the syntax is pd dot concat. Then you need to pass the list of data frames, list of df1 df2 on axis 1, where you wanted to concatenate axis 1. You need to specify the axis also, axis 1. Then if I will give this df concatenate, then I'll be able to see the data, concatenated data. So this is my first data frame, this is my second data frame, both are concatenated on axis 1. So if I don't give this axis 1, if I give 0, now you can see I got all the null values of ticket price. These are I mean merged or concatenated on axis 0. So if I pass 0 here, what is happening? Because I have a common column of survived, so that is presented, and also age is also there in both the, sorry, age is only it is taking the age from the df1, and df2 survived column is not, because it is a common column, and also null values are there from the df1. So that is how it is, since I just applied head right. So that is why I'm getting this null values. So if I look at the concatenate, so this is my entire data set with the uh, this is, it is like one by one, not side to side concatenation. It is concatenated on axis 0, like row wise concatenation. If I give axis 1, the column wise concatenation. That is different, that's it. So this is how you can concatenate, or you can join, or you can merge the data sets. And also this is about and next thing is date and time manipulation. So if I have a column with some dates and I wanted to do some manipulation on the date, so I do not have the date column in the above data set. That is why I created a new data column, and I created a new column with the df of date, and I'm importing pd dot to date time. So this is my new column with the date 1/1/2023. So all the columns will be filled with the same date, because I'm giving the same date for all the columns. So that is why you can see all the same columns, sorry, similar elements in all the columns, because I just give only one element or one date. So this is how you can define, or you can add a date column by using pd dot to date time. And if I wanted to extract the year from this date, so I have this 1/1 of 2023. I don't need all the month, date, year values. I just needed only year. So that is also we can extract it by doing I'm creating a new column like df of year, and with the, because my date is present in the date column, df dot date dot dt dot year will give me only the year. So here you can see a new column will be added with the year 2023. This dot date dt is like dot dt dot year will give me the only year is extracted from the date column. So that is how you can extract the year. Similarly for month, dot dt dot year, and for month dot dt dot month. For year, and for month it is dot month. A new column will be added with the respective month. For January it is 1, so that is why it added 1. So that is how you can create new columns from the existing date column with a year or with a month. And next we are going to talk about some advanced indexing. So setting an index, if I wanted to set the index, so now df dot set underscore index, this will set the new index, set a column as the index of the data frame. So now I wanted to set the index to a new column, age column, in place is equal to true. If I give that, then the index will be changed to age. So if I see, so now it got changed. See, it has become, the column has become the index. So that is how you can set the indexes. And if I reset the index, so now reset the index, in place is equal to 2, then the index will be resetted to the default values. So df dot reset index, it will be the index will be reset. df dot reset underscore index, then the index will be resetted. So now you will be able to see the old original index. So that is how you can reset the index. And this is we can do some multi-indexing. You need to pass the columns, and you need to pass the, I mean, the condition in place is equal to true, so that the changes will be saved into the original frame. So these two columns become the index of the data frame, and that is how we can do. And this visualization is like already we discussed separate videos, but I just wanted to include a simple basic plots, basic plotting, plot data using matplotlib. So df dot in, I mean, reset index, I wanted to plot on x-axis age, y-axis ticket price, my ticket price. I wanted to see the data distribution between age and the ticket price. See, this is how the data distributed if the age is ticket prices and age. So this is how you can see the distribution by using scatter plot, because I specified kind is equal to scatter. And also if I wanted to plot a single column histogram, I need to pass the column, and also dot hist will give me the single column histogram, the frequency, age groups, number of bins also I can specify. So or else it will directly take the default value. So this will give me the frequency of that particular age group. So this is how you can apply histogram and box plot on a single column. You need to column is equal to fair. That is how you can get. And scatter plot with the two columns, and x and y versus same age versus ticket price. And that is how we can plot some basic plots in pandas. And accessing data by position, so I lock we are like I can able to get the data. I can able to sort the data with a by positioning nothing but the index position. So this is for a row position, this is for a column position. So 0 and 0, 22 is there. So that is why I got the 22. That is how you can use this ilock. Ilock is for get accessing the data by position, and normal log is like accessing the data by labels. Like I wanted to get the only for two rows, then I need to pass the row label and column label respect to row and the column. So that is how you can access the data by this lock method. This is for accessing the data by label, and this is by the position of that element, and cutting the data into bins. The pd dot cut df of page and bins is equal to 5. So this is also we can get a bin data. We can able to cut the data into bins by using pd dot cut, and calculating the correlation. So df dot correlation will give me the correlation about all the elements, like how the elements are correlated together. Df dot correlation will give me. And also if I wanted to look at the covariance matrix, df dot covariance, so this is how you can see the covariance matrix. And if I wanted to remove some outliers by using some condition, like df dot column name lower bound I can give, and upper bound I can give, like I just give the sample condition. I need to pass that required column name, and I need to pass the, like, filtering the data. I just whatever the data I just not needed for the further processing, so I can also remove those things. Those are nothing but the outliers, which is there is no effect if I delete those data points also. So that is where I can able to delete those outliers. And also if I wanted to look at any duplicate values, that is also I can see. So if I do only df dot duplicated, I'll get the uh, a data frame with a boolean values true false. So where there, if there are any duplicate values, that particular cell will be filled with the true and the remaining cells will fill with false. I don't need that. I just wanted the sum of the duplicated elements. So I have 107 duplicate values. So that is how you can look at the duplicated values. And if I wanted to drop the duplicated values, so this is the syntax: df dot drop duplicates. And if I wanted to look at the data, so this is my data after removing the duplicates. So if I see some, now if I already I dropped the duplicate value. So if I look at the duplicated values, so in place is equal to true, I need to pass. I need to save the data explicitly. Then only df dot duplicates, or it was already we dropped it, right? That is the reason why we are getting this error. So that is okay. This is the syntax. We can do df dot duplicates, so it will be able to delete the duplicate values. And these are like sample string operations. We already discussed about all the string operations in str accessor in detailed description, how we can apply all the functions like upper value, lower value, capitalize, something like that. So this is what, if I wanted to get the upper values in some particular column, then I can do str dot upper. And if I wanted to find a substring, if it is there like find, then you need to pass the substring value str dot find. If I wanted to replace the string, so you need to pass str dot replace. You need to give the old name, then what with value you wanted to replace the string, you need to give the new name, then it will get replaced. So that is how you can do, and some string operations. So this is my new column I just created, John Doe, and I wanted to split the string with the space. So that is also we can do dot str dot split, and I wanted to split with the space. That is why I just given the space with the double quotes and expand is equal to true. Then it will create a new column of df of name with splitting the name John Doe. So here you can see it got split into two, first name and last name, and first name is John, last name is, it got split. So that is how you can do splitting and applying some functions. Some customized functions also we can apply on a column. So here I just created a fair column, and I just created this lambda function x is equal to x square. So doubled fair existing. If my original fair is 1, I wanted to double it. I just wanted to create a new column by using as customized functions. I created this apply. So with this apply function, you can able to apply the customized functions. Here my element x has to be replaced with x square, like double. So this is how you can do some, or you can apply customized functions. So I think I have made some changes above. That is why I'm getting this errors. So but the syntax is correct. If I wanted to apply the like ticket price, right? So that is why I'm getting like this ticket price. Okay, this is about applying customized functions. And pivot, again we already discussed about pivoting data frame, like you need to pass the index value, columns and the values. And also you need to pass if you needed aggregate function, you can pass the aggregate function as well. And also this is about some advanced analysis, like cumulative sum. I just created a cumulative sum with a fair cumulative sum and rolling mean. So that is how you can do some advanced operations, also accumulating some rolling mean. So this is how you can calculate the rolling mean. And this is expanding mean. This is how you can create the expanding mean. And so grouped functions, so same thing we discussed about grouping two columns together with a rank function. It will give me the rank. And the transforming the data, like it is like normalizing or normalize a column values. So this is how we can do it. And if I wanted to, I'm ready, all the operations are done, I just wanted to save the data frame or export the data. So this is how I can export df.to. If I wanted to save it to csv format, so this is how I can save. And if I wanted to save with the excel file, I need to pass to excel file, then the data frame will be saved in excel file. So this is how you can do some data manipulations by using pandas. So I think I have covered everything. So if I wanted to talk about all the things, it will take a lot of time. So that is the reason why I just covered uh, most of the things which is necessary for exploratory data analysis, and also while preparing a machine learning model, so you may come across these many things. So I hope I have covered everything. So you guys have any questions, then please feel free to comment on the video so that I'll be able to come up with some answers. So if you are enjoying the content, or if you are able to getting something out of these videos, please like the video and also share it with your friends who is a aspiring data scientist who is looking into these kind of things. So please share these kind of videos with them, and also please don't forget to subscribe the channel. Thanks everyone. Bye.